Okay, so let's go ahead and move on to 5.6. In 5.6, we're going to talk about inequalities in two triangles. Okay, so we initially talked about inequalities in one triangle, right? Earlier, we talked about within one triangle, right? If we have the shorter side is going to have the smaller angle. The longer side is going to have the larger angle compared to the two, right? That's what we talked about. So it's within one triangle. Now we're going to talk about two different triangles in two different triangles, okay? So what we're talking about is it's called the hinge theorem. Really, it's called the hinge theorem, okay? So we look in the page 352, it says 5.6-1, the hinge theorem. If two sides of one triangle are incongruent to two sides of another triangle, and the included angles are not congruent, then the longer third side is across from the larger included angle. If I have two triangles, 1, 2, 1, 2, okay, where this guy is the same as this guy is the same as this guy, okay, now we're going to have a third side here, right? We're going to have a third side, this third side versus this third side, okay? This angle here is smaller than this angle, so therefore this is shorter than this side, okay? So in other words, if I have two congruent sides here with different included angles, then the larger the included angle, the longer this other side, okay? That's what they're saying. The converse is that if two sides of one triangle are congruent to two sides of another triangle and the third side are not congruent, then the larger angle across from the larger side, then this larger is going to be over, this guy's going to be larger than that. This is going to be the larger one, this is going to be the smaller one if you compare the sides. That's the converse. Okay? All right, so that's the hinge theorem. The reason why it's called a hinge theorem is because if you think of this thing and these two sides being the same, but they're hinged together at this point, so as you lower it and you open it, you would do a hinge, that's what they're talking about here, okay? Okay, so that's why it's called the hinge theorem. Okay, so let's go ahead and see if we do example number 1. Compare angle PQS to angle RQS. So, and example number 1, the first one we have this, and we have what? We have 7, 7, and 5, and this is 5.3, this is 5.1. So, since this guy is the same and these two guys are the same, we have a hinge thing here going on. We have two sides that are congruent between this triangle and this triangle. Since this has the longer side, that means that this angle here is going to be larger compared to that angle. And the reason being is because this side is longer than that side here, according to the hinge theorem, okay? Next one, we're going to have K, L, M, N, and this is 6, this is 6, okay, and it shares this side here is shared. So again, we have a hinge thing going on here, and we have 53 degrees, and we have 57 degrees here, right? So therefore, this guy, MN, is going to be larger or longer than KL, because this angle here is larger, right? Because you have two sides here that are shared, this guy and this guy, this guy and this guy. Okay, so that's that. And then we have C, the last one. We have just like this. And we have 24, 25. TUVW 6x minus 3, and we have 45 here. And we have this guy is the same as this guy. So we have a hinge theorem going on here because this guy is the side that is shared. These two sides are congruent, okay? So this is 25 longer than the 24. That means that 45 is going to be larger than this guy. So your 45-degree angle here is going to be larger than the 6x minus 3. So if I solve this, I add 3 on both sides, divide by 6. And so that's that. And also, this has to be greater than 0, right? 6x plus 3 also has to be greater than 0, right? So I should have solved this together, and I can solve this here. I'm going to add 3 on all sides, like that, and divide everything by 6. So it's going to be what? 8x.5. Okay, so that's that. Let's do example number 2. Example number 2. Entertainment application. Angle of a swing in a circular swing ride changes with the speed of the ride. The diagram shows that the position of one swing at 2 different speeds. Which rider is farther from the base of the swing? Okay, so you have one that's like this, and then you have one that's like this. Okay, well, obviously, this is the same as this. This never changes, right? And the person riding the chain doesn't change either. So that's the same. Okay, so the larger here, right? So this guy here is going to be larger than this guy because this angle here is going to be larger than this angle here. Okay? Flip the page, go to page example number 3. Example number 3, we have a triangle like this. And then we have a triangle like this. L, M, P, K, N. Write a 2-column proof. Given that KL and NL are KL and NL. So KL and NL is this guy here, are congruent. Okay. And prove that KM is greater than, we're trying to prove that KM is greater than NM. Okay, well, KM and NM, right? So you're looking at a hinge theorem where this guy is the same. So you hit this guy and this guy versus this guy and this guy. Well, this angle here is larger than this angle here. Therefore, KM has to be greater than NM, right? Does that make sense? I'm not going to go through the two-column proof, but just think about it, right? Think about it. So if you have this guy as the hinge, this guy is the same, and this guy and this length are the same. So you're opening the hinge from here to here, okay? So therefore, this is going to be smaller than this guy, okay? All right, so we're good, we're done.